Hi, students. I noticed that some of you had trouble with the counting principle last week, so I'm going to start with that. Then we're going to talk about permutations, also sometimes called arrangements, and combinations, sometimes called groups. For the counting principle, given multiple events or choices, you multiply the ways that each event can occur, or the number of choices. So if you're choosing a dinner, and you can choose from steak or chicken for the main course, rice or potatoes for the side, and tea or water to drink. You have steak or chicken. With each of those, you can have rice or potato. And with each of those, you can have tea or water. So if you count down the last side here on the right, you have 1, 2, 3, 4, 5, 6, 7, 8 different combinations, 8 different meals you can create. That's because there are 2 times 2 times 2 or 8 possible dinners. So you multiply the number of ways that each thing can occur. You have 2 choices for the main course, 2 choices for a side, 2 choices to drink. You have 2 times 2 times 2 or 8 possible dinners. How many outfits can you have? Mahood packed light for a trip. He brought 2 pairs of pants, 3 shirts, 7 pairs of socks, and 2 pairs of shoes. How many outfits can he wear? Well, you multiply the number of pairs of pants, which is 2, times the number of shirts, which is 3, times the number of socks, which for some reason is 7, times the number of shoes, which is 2, presumably 2 pairs, not 2 shoes. So we have 2 times 3 times 7 times 2, 84 different possible outfits that he could wear based on what he brought with him. For passwords, this is where people tended to get confused. How many passwords can you make with 3 letters from A to Z, 4 digits from 0 to 9? Keep in mind that from 0 to 9 is actually 10 different digits. Now, each letter can have 26 different possibilities. We have 3 letters, so there are 26 letters for each. 26 times 26 times 26. We have 4 digits. There are 10 possible digits, so 10 times 10 times 10 times 10, and you multiply all of this together. 26 times 26 times 26 times 10 times 10 times 10 times 10 is 175,760,000 possible passwords. That's just with 3 letters and 4 digits. Most encryption is actually much stronger than that. How many ways can you arrange 4 pictures? This is a typical type of probability question. How many ways can you arrange this? How many different batting orders can you have for your baseball team? Or how many different pitching orders can you have, for your starting pitchers? How many ways can you arrange things? How many ways can people line up? Those are all questions that have to do with what we call permutations. So how many ways can you arrange 4 pictures? I have 4 pictures here. I got 4 spots. I could just put them up however I want. There are 4 different pictures, so I can choose from any of those 4 for this first spot. But once I've chosen one, now I only have 3 to choose from. So for the second spot, there are 3 to choose from. Once I've chosen one, there are now only 2 to choose from. I pick one, and I only have one left, so it has to go in the last spot. So there are a total of 4 times 3 times 2 times 1, or 24 different ways to arrange those 4 pictures. 4, because that's how many I have, times 3 times 2 times 1. These arrangements can also be called, as I said, permutations. Now, how many ways can I arrange it if I only want to hang 4 out of 10 pictures that I have? I've got 10 pictures, but I don't have that much wall space, so I'm going to only hang 4. How many ways can I do that? Well, to start with, I have 10 pictures, so there are 10 different ones that can go in that first spot. I hang one up. Now I have 9 to choose from. Throw the 9 in the second spot. 8 left to choose from. 8 in the third spot. And 7 left. So 7 in the fourth spot. If I had room, I could keep going and do times 6, times 5, times 4. I don't have that much room. I'm only going to hang these 4. That means that I've got 10 times 9 times 8 times 7 ways to arrange them. So 5,040 different ways that I can arrange 4 out of the 10 pictures. Wow. Now, with permutations, the order matters. When you talk about arranging things, it matters what order you put them in. When you talk about a password or a digital code, it matters what order you put things in. We have 4-digit codes. The 7854, 4785 are two totally different arrangements of the same group of 4 digits. In fact, there are 4 times 3 times 2 times 1 or 24 different ways to arrange these 4 digits. And that's only the set of digits that include a 4, a 5, a 7, and an 8. So I've got 24 different possibilities here just with those 4 digits. Now, combinations, the order doesn't matter. So if we look at this on a large scale, if I want a 4-digit number, there would be 10 times 10 times 10 times 10, all the numbers from 0000 to 9999, which is 10,000 different possible 4-digit numbers. Now, if I don't want any numbers to repeat, that's a permutation. So I've got 10 times 9 times 8 times 7. I have 5,040 4-digit permutations of this. That's if there's no repetition. But it still includes a lot of duplicate sets of 4. So how many different groups of 4 digits are there if the order of the digits really doesn't matter? That's called a combination. So 4-digit combinations. There are 5,040 different 4-digit permutations. How many groups of 4 digits are there? Well, each of these 4 groups of 4 digits can be arranged in 24 different ways. That's how we end up with so many different permutations. If we divide the number of permutations, in this case 5,040, by the ways to arrange the digits we kept, which is 24, we only have 210 combinations. That's sets of 4 digits, with the order not making any difference. Let's do a couple of examples. This first one is a permutation. How can you choose a president, a vice president, and a secretary from a group of 8 candidates? There's nothing here that says this has to be in order, but these 3 positions, president, vice president, and secretary, are very different jobs. So it does matter what order you select people in. Whether you select somebody as president or secretary could make a very big difference. So this is a permutation. In this case, the notation would be 8p3, meaning that we have 8 things. We're taking the number of permutations of 3 of those at a time. And since there are 8 of them, we start with 8. And we do the next 3 factors, 8 times 7 times 6, which is 336. So there are 336 different permutations of taking 3 out of these 8 candidates to be the specific positions of president, vice president, and secretary. Now, if we wanted to do a combination, we can say, well, what if we just took a committee of 3 people? Let's not give them titles. We'll just put those 3 people in charge. So we have a committee of 3 people. Now, when I decided to do that, there are a couple more people to join. So we got 3 out of 12. The 3 people on the committee, doesn't matter. We can choose them in any order. So this is a combination. The notation is to say we have 12 people. We're choosing the number of combinations 3 at a time. Well, if we did 12 times 11 times 10, that would be the number of permutations. Way too big a number. We're going to divide that by the number of ways to arrange the 3 we keep, which is 3 times 2 times 1, or 6. So we have 1,320 divided by 6. We have 220 different combinations. So there are 220 different groups of 3 people we can take out of a group of 12. In terms of notation, permutations, choosing 4 of 10 things, we would say we have 10 things, number of permutations, taking 4, 10p4. That's the same thing as 10 times 9 times 8 times 7, the first 4 factors starting at the largest number, 10. For combinations, we do the same thing to start with. It's 10 choose 4, and we do the number of permutations, and then we divide that by 4 factorial. That 4 with an exclamation point means 4 factorial, which means it doesn't mean 4 as in golf. It's 4 times 3 times 2 times 1. If it were n factorial, it would be n times n minus 1 times n minus 2, all the way down to 1. Okay? So 5 factorial would be 5 times 4 times 3 times 2 times 1, which is 5 times 4 factorial. Okay, so that's the notation. Now you can do these permutations, combinations, and factorials on your TI-83 or TI-84 calculator if you have one. You don't necessarily need them for this. This stuff is pretty easy to do without it. But if you want to use the calculator for it, under the Math button, you scroll right to where it says PRB, that's probability, and then choose NPR, which is the second one down, and CR, the third one down, or exclamation point, which is factorial, which is the fourth one down. So if I wanted to take the number of permutations, taking 4 out of 10 things, I would say 10 before I hit the Math button. 10, Math, scroll over to where it says PRB, go down to where it says 2 colon NPR and hit enter. Type in 4, hit enter. You can probably hit just the 2 instead of scrolling down, but it doesn't matter. Now, if you want to do combinations, it's not any harder. You just say, okay, I want to take 4 out of 10 things as a combination. I type 10, then the Math button, scroll over to where it says PRB, scroll down to where it says 3 NCR, hit enter, type 4, hit enter. That's it. Basically the same thing. So you just need to know, is it a permutation or a combination? Now, if for some reason you want factorial, you can do almost the same thing. You type 4, hit the Math button, scroll over to PRB, go down to 4 colon exclamation point and hit enter. That's it. Okay, so have fun with permutations and combinations and turn everything in. That's it.